Okay, so let's start creating some standardized residuals just to show an example of doing it manually and then with R's default built-in functions. So if I do data empty cars, for the motor trend cars data set, my Y is miles per gallon. In this case, my X is an intercept, horsepower, and weight. Okay, I define my N and my P. I create my hat matrix, and then my what I'm calling the residual matrix as just being I minus the hat matrix, and then my E is my residmat times Y. So residmat is the matrix that is orthogonal to the projection onto the space spanned by the columns of X. Okay, and then my residual variance estimate is the sum of the residuals squared divided by N minus P. And then my standardized residuals are just my residuals divided by S divided by the square root of the diagonal of the residual matrix. Okay, and then if I compare those, these are just exactly with what you get if you take the output of your fitted LM object, okay, and here I'm just putting in my design matrix, which includes an intercept, so I'm subtracting out R's default intercept, and then the function R standard for standardized residuals is what returns the standardized residuals as we just calculated, and you can see here they're identical. What you want to look for in standardized residuals, so I would just want to do something like plot R standard by predict, and then I should have assigned my output of my fitted object to a variable, but I'm just going to refit it there. And you usually want the predictive values on the horizontal axis, and then you get your residuals versus, there we go, then you get your residuals versus your fitted values plot. And when you want to look for, when you look at these plots, is any obvious patterns or systematic relationships, for example, variances increasing with the predictive value or things like that. Often you usually want to add a horizontal line at 0, because since we've included an intercept, our residuals have to sum to 0, so they at some level have to be distributed above and below 0. And we're just doing our residual plot, only now we know that the interpretation of this -1 and 2 here are in terms of residuals being -1 or 1 or 2 standard deviations above or below the mean of the residuals. The mean of the residuals, again, being 0 in this case. Okay, so that's a pretty easy trick to get your residuals on a more interpretable scale. Now we're going to go through and talk about other kinds of standardized and special kinds of residuals that take on a particularly nice form in linear models.